Warning: this reaction may produce chloroform vapors. Chloroform is somewhat harmful, so work in a well-ventilated area. The chloroform should also be stored with a small amount of pure ethanol to prevent the formation of deadly phosgene gas. If you're a professional chemist or chemical engineer, you're most likely working in a climate-controlled laboratory with a proper fume hood and a bunch of other fun toys. But if you're a broke chemistry student or some other form of home scientist, chances are you're probably working in your garage or backyard. I'd say I'm more of the latter. Don't get me wrong, working in your yard has its advantages, such as unlimited ventilation, but it also comes with a few distinct disadvantages, specifically the weather. When you work outside, you're at the mercy of the elements, and not just the chemical ones. Essentially, you're forced to plan your syntheses around a 7-day forecast, and if it snows or rains, tough luck. In this preparation though, I'm actually going to be using Oklahoma's brutal and unforgiving weather to my advantage, so I can perform a reaction I've been waiting to do for years. The Haloform reaction. That's right, it's chloroform day. To make chloroform, we only need 2 ingredients, a hypochlorite and a ketone with at least 1 methyl group. I went with plain liquid bleach because it's one of the cheapest and most available hypochlorites, and acetone because it's bought easily as a nail polish remover for less than $1. In total, these ingredients cost me less than $10 at Walmart. Now, before beginning the reaction, you'll need to cool down the reactants to 0 degrees Celsius or colder, since the reaction is highly exothermic and could otherwise boil away the chloroform. Like I mentioned, I'll be using the weather to my advantage, so I just left my chemicals out in the cold winter air for a while before using them. And for those curious, yes, it is in fact snowing. When everything is ready, add about 90 milliliters of acetone to each gallon of bleach. It's important to use an excess of bleach because if any acetone remains unreacted, it will form a mixture with the chloroform that's nearly impossible to separate. I titrated my bleach using hydrogen peroxide to find its concentration, and then calculated the corresponding amount of acetone I needed to add. Once all the acetone is added, cap and shake the mixture. Be sure to vent the bottles, since chloroform tends to build up pressure as things heat up. At the peak of the reaction, the temperature rose to almost 40 degrees Celsius, which was pleasantly warm for someone like me staying out in the cold. I endured the warmth of the reaction for a few minutes, and then set everything aside and let it react overnight. In the morning, this is what I found. It snowed throughout the night. This was actually after some of it melted. I really should treat my video backgrounds better. But anyways, the next step is separating the chloroform from the remaining solution. Chloroform is insoluble in water and sinks to the bottom of the jugs, so we should first pour off the upper water layer. I used a chopped down 2-liter bottle to help with this. The final bottom portion of each jug was then added to a separatory funnel and the lower chloroform layer was drained off. Now, you may be tempted to just stop here and keep the chloroform as is. Some impurities will still be present in the chloroform though, so I recommend distilling your product to ensure its purity. At first, the chloroform that comes over will be cloudy and tainted with water. To prevent this, I recommend adding some anhydrous magnesium sulfate to the chloroform before distilling. I ended up just drying the cloudy portion and adding it back into the boiling flask to redistill it. You can see here the difference the magnesium sulfate makes. After distilling, we're left with 115 milliliters of reasonably pure chloroform. This is actually a very good solvent for laboratory purposes, and I'll be using it as a reagent in an upcoming video when I attempt to reduce it to a much more common solvent, dichloromethane. For now though, I'll leave you with some footage of me doing something you should absolutely never do: burning chloroform. Chloroform doesn't really sustain a flame when lit, but it does let off a whole host of toxic gases as it reacts with oxygen in the air. One possible product of its combustion is phosgene, an extremely toxic compound which was once used as a chemical weapon. Needless to say, you should never try burning chloroform. I did it, so you don't have to. Anyways, there you have it, making chloroform from bleach and nail polish remover. If you'd like to support videos like this, feel free to donate or support my work on Patreon. The links are in the video description. Remember to like, subscribe, and comment, and I'll see you next time. LabCoatz out.